Okay, so we have here a picture of a relay, and I want to explain something that not all of aware about, but let's talk about it. So we have here a coil, and when we supply voltage, so there is current and there is magnetic field inside the coil, and then we can see that there is additional spring here, and when we supply current, so this pin is magnetized towards the normally open one, and then we have contact between the common and the normally open when we supply current. If we are not supplying current, so there is no force, so the common is connected to the normally closed. As this is called normally closed, meaning without current it's normally closed and conductive, and this is normally open, meaning we have to supply current in order to make it conduct. But what another important thing is the time. Okay, what is the time? The time, if you will open a data sheet of a relay, so we have something that it called operation time, and we have a release time. So we have operation time and release time. What does this mean? This means that when we are supplying current, it takes some time till it's conductive. Why this happens? Because we have, let's say, to charge the coil in with current, and it is taking some time to charge the current till we have the magnetic field, and then just then it will conduct. Also the same about releasing. When we are stopping the current and we don't have voltage and current, it takes some time to release the conducts. Why? Because the coil needs to discharge, and it takes time. Okay, so the current, it takes some time for it to charge and takes some time to discharge the coil with the let's say with the iron that is used. We have usually an iron, and the coil is bended over the iron. Okay, so we have the timing. So now I want to use, if I want to use such a relay for let's say welding or something like this, so I need to know the time, because if I, for example, want to use a spot welder using a relay or solenoid and not using MOSFET, so it will take some time, and the time is critical when transferring very high current. Because if we are using, for example, supercapacitors, so we want to control this by milliseconds. Okay, we want milliseconds. For example, if we want a very let's say low spot, so we will want it to be about 1 or 2 or 3 milliseconds, and if we want to transfer all the energy from the capacitors, it depends on many things, but we want it to open or to close for more time, for example 10 milliseconds or 20 milliseconds. Okay, so by the way, the orange is the box, and we have all the wires here. So 2 wires are for the coil, and another 3, one is the common and the normally open, normally closed. Not all the relays have a normally closed. Some of them just have 4 wires, 2 for the coil and 2 for normally open or normally closed, one of them. Not all of them, and some of them have more wires and more conductive and more outputs, let's say, but it depends. It's same like in a regular switch. So now I want to measure the time, because I'm not let's say satisfied with the data sheet that I get from for the manufacturer. So I want to build a circuit and to find this time. So eventually I did it, I took an Arduino and I built a circuit, let's say a very simple circuit, and I'm measuring the time of the relay, the turning on and turning off. This is quite simple, let's say, programming. It's not too sophisticated, but there are some. Why do I have this on the LCD? Maybe I will send it back to the seller in China, but never mind. Okay, so let's see how this is working. So what I did is I will share, of course, my code later in my site. You can download it and use it and see that it is working. By the way, it is now counting the milliseconds. So what I did, when I'm pressing the up button, it will supply the relay the voltage to turn on, and then it will measure how much time till it really turn on. And how I'm doing this, I'm just taking 5 volts through the relay and getting the back from the relay to the analog input, and I'm reading the analog input. And when the analog input see a change, then it is stopping the timer and giving me the number. So let's see how much time, and then we will check in the data sheet, and then maybe I will try with a scope to see if it is accurate, because we have also the delay of the code, etc. But eventually I think it should be pretty close. So turning on the relay, and the on time 10 milliseconds, and it will write now the off time 2 milliseconds. Of course it should be more or less repetitive, so again turning on, now it is 9 milliseconds, so it is pretty close, and the off time is 5 milliseconds, so we have 10 on and 5 off. Again 10 milliseconds on time, and off time 5 milliseconds, which seems that it's pretty accurate. We have between 9 and 10 milliseconds the on, and the off, see the off was 1 time 5, 1 time 4, 1 time 2, and again 9 milliseconds on and 1 milliseconds off. Whoa. Okay, so the off is much faster, the on time is consistent between 9 and 10, and the off time is, most of the time it shows 5 milliseconds. So we will check it, and now off time now 1 millisecond. Now I will try to use and check this relay. Now because this is 5 volt and this is 12 volt, so I will power this relay through this relay, and then I will measure the time for this relay. But now I have to keep in mind that since the on time is 10 milliseconds, so the number I will get here, let's say it will be 17, so I have to do 17 minus 10, and it will be 7. And also for the off time I have to decrease 5 because I'm powering it through this relay. So maybe before doing it, let's see with a scope if this is reasonable what I'm getting. Sorry about the flickering, I'm a little surprised, I have to admit, because I wasn't expecting this. I will show you when I'm running it. So I can see the trigger, the time is 4.2 milliseconds, while here it says 10 milliseconds. So eventually something with the code is not accurate, and probably it takes time till it turns the GPIO. This is why using a scope for such a thing is eventually important. You can see that it is repetitive. The blue is the power to the relay, and the red is when the relay is on. So it takes 4.2 milliseconds, while the software show 10 milliseconds, which is about twice the time. Now I will check to see about the off time. The off time, I will trigger on the off time. The off time here is, it shows sometimes 0, so let's see what is the meaning of this 0, because of course it can't be 0 anyway. So now I'm triggering on the off time. So let's run the scope, and we can see that I have to trigger on the negative and not on the positive. So I will change my slope now and wait for the relay to close, turn off. Okay, so the off time is eventually something similar, also take about even more than 4 milliseconds. This is a little strange, I have to admit, wasn't expecting this. The off time is 4.5. Let's repeat the test. So run the scope, wait for the relay to close and see the time. Okay, so the off and the on time both seems about 5 milliseconds, and the software is somewhat not accurate by measuring this number. Probably the A to D takes, but I read the manual, so it should be less than 1 millisecond, and maybe the code is 1 more milliseconds. But eventually I'm a little surprised about the results, and also don't understand in the scope, in the on and the off, most of them about 4 milliseconds, so I would expect to see same numbers on the software. So after doing some tests, I've done calibration to the software. So you can see on time 5 milliseconds. Sometimes you have to use the software in order to calibrate. Off time is 5. Again, we'll do some tests. On time 7. Little strange, but off 5. By the way, I've added 2 pull down resistor to the analog in. On time 6. Okay, if I have 2 milliseconds difference, so this is acceptable. And off time 5 milliseconds, again 5. So we can say 5 and 5, and I've calibrated the software, so it's pretty good. Now we will measure the other relay to see the difference. So again, the numbers that we will get with the bigger relay, we had to subtract 5 to each of the results that we will get. Okay, so I've connected the relay, and now let's see the results. Okay, so of course I expect to see much higher numbers than 5 than we've seen before, and this is because there is additional relay, and we have to subtract from the number we get, we have to subtract 5 on the on and on the off. So let's try it. So pressing on, so we can see 16 milliseconds minus 5, so it's 11, and 14 minus 4, it's 10. Let's see if the results are consistent. So we have 15. First we can see that the circuit is working, it is doing something. 15 and 13. Not always exact the same number, but more or less, let's say more or less, we can see 16 and 14. Again, minus 5. We have to do minus 5 because through this relay I'm powering the other relay. So that's all. So you have to know that the relay has an on and off time. For example, this one, if the off time, not the on, never mind, but if the off time is taken 10 milliseconds, So we cannot use it for a welder, because if you want 1 millisecond, so there will be much more energy than we need. That's all. So I will put later a code with what I wrote for this to work, and that's all. Hope you enjoy. Thank you and bye.